Okay, my friends, I really want to go home. It's 3:10. Thanksgiving week. I could have left a half hour ago, but I am getting this section 6.2 done for you, so I hope that you can find some time to get it done over this break. I feel so bad assigning homework, but it's a college class, right? Okay, we got this. Example 2. So, first thing I want you to notice is that this equation right here is already missing y. So, since that happened, we should get rid of y in the other two equations, right? So we're going to use those and get rid of y. Rid of y. How exciting. That, like, decreases the amount of work we have to do. Okay, so to get rid of y, we need to multiply the top equation by a 3. So we're going to multiply this whole thing by a 3, and then we will have a positive 9y and a negative 9y, and we'll add those together, we'll have a new equation, and then we can go from there. So that gives us 6x plus 9y minus 3z equals 3. And then this is just going to stay as is. 4x minus 9y plus 2z equals 5. Add those together, we get 10x 0y negative 1z equals 8. All right, well now we have that middle equation with y missing. We have a new equation with y missing. So now let's take those two together and eliminate something else. So we can either eliminate x or we can eliminate z. Z looks pretty easy to eliminate. We just need to multiply one of our equations by a negative 1. So I'm going to take this whole thing, multiply it by a negative 1, and that will give me this problem here, 10x minus z equals 2. And then multiply by negative 1, we get negative 10x plus z. I don't know if you can see what's going to happen here. But when we add these together, we end up with 0x and 0z and a negative 6, which is impossible. So this is no solution. And we refer to that as inconsistent. I'm just going to circle it. Inconsistent. All right, that only took me 3 minutes. Let's go to the next one. Solve the system if possible. Classify the system as consistent, independent, da-da-da. We know the drill. Okay, all three of these equations have all three variables intact. So we're just going to have to choose something and see what works. We could get rid of x first, or we could get rid of y first, or we could get rid of z first. X definitely looks easiest because we can multiply this by 2 and add it to this one, right? And then we can multiply this one by 4. Oops. Multiply this one by 4 and add those together. Does that make sense? Okay, so multiply this one by 2. So multiplying by 2, I get 4x plus 6y minus 6. Oops, I'm messing up again. Oh, I gotta erase it. Minus 12z equals 2. Alrighty, then we have the negative 4x minus 6y plus 12z equals negative 2. Let's add those together. So we get 0x plus 0y, oh my, plus 0z equals 0. Oh, this is always true because multiplying by zeros and adding them together is always going to be 0. All right, well, we have infinite solutions, and that means it is consistent dependent. Now remember in one of my previous videos I said, oh, I should look and see how the answer key makes these look. Well, I have figured out how they want you to leave your answer. So here's what we're going to do. For our answer, we are going to let z equal whatever. Any real number. But we're not just going to leave it as z. We're going to change it to some parameter t, which is really not necessary, but it is what your answer key does, and so I want you to see this so that you're not confused by where did this t come from. Well, they're just saying we are going to let z equal t for any real number t. Okay? Once we know what t is, we plug it in anywhere we have z, and we solve for our x and y so that we have equations that allow us to solve for x and y in terms of z. But we want an equation that just has x and z, and we want another equation that just has y and z. So we have a little bit more work to do here. So let's start by taking different equations, like maybe 1 and 3. We were about to try to get rid of x earlier. If we hadn't come to this part here, we were going to do this. We were going to do these. Well, I wonder what would happen here. Can we get rid of the x's and manage to keep the y's and the z's so we can solve this for y? I think we can. So our original plan is going to work here. We did 1 and 2 equations and we got this situation. So now we're going to do 2 and 3. So we'll have negative 4x minus 6y plus 12z equals negative 2. And then we're going to have 4, oops, undo here. Oh, that undid everything. I'm just going to redo and then erase. Okay, so multiply by 4, that gives us 4x plus 8y, we're not going to get a 0 there, plus 20z, I didn't forget to multiply my 4 and my 5 together this time, equals 40. Okay, add those together, we get 2y plus 32z equals 38. So let's solve this for y. So 2y equals negative 32z plus 38, and then divide everything by 2. So I got a phone call, I'm not sure exactly where I left off, but I think I was about to divide by 2, which gives me y equals negative 16z plus 19. Now, to put that in our parameter form, we're going to replace our z with a t, and now this is our answer for y based on parameter t. So no matter what value we pick for t, we can plug this in this equation and find the value that goes with that for y. Now we need to do the same thing for x, but it's a little bit easier just because we already have this one solved for y, so we can take that and plug it in somewhere else and use it to find x. So we're going to use, maybe this last equation will work well. So we have x plus 2y. Look, I'm just going to get back to what I had earlier because I already had 2y, right? Well, I'm just going to write it out. So negative 16t plus 19. And then we're going to, that equation has a 5z, but z is now being represented by t. And we have a 10. So we get x minus 32t plus 38 plus 5t equals 10. We solve that whole thing for x. This adds up to negative 27, so move that to the other side and it's positive 27. Move this to the other side, 10 minus 38 is negative 28. That is our parameter for x. So now if we want to put this all together into a coordinate, we have our x value is 27t minus 28, and then we have our y value, which is negative 16t plus 19, And then we have our z value, which we're representing with parameter t. And here is our answer. So any t value we plug in to find y and x, and we have a coordinate that works in all three of these systems. Now, what does that look like graphically? We haven't really talked about these. There's some excellent pictures of it in a book. In the book, not a book. Maybe I will try to pull those up and show them to you in a future video.